Let's talk about how we can use trigonometric substitution to do integration, and then I'll give you a chance to try a couple. First thing to remember, the derivative of inverse sine is 1 over the square root of 1 minus x squared. The derivative of inverse tangent is 1 over 1 plus x squared. Now, trigonometric substitution is often used as a point where regular substitution doesn't work and integration by partial fractions or parts doesn't work. So, for example, this one, you can't make substitution work because making 16 minus x squared your u doesn't help you get rid of this numerator. And while you can factor this because it's under the square root, it doesn't really allow us to use partial fractions. So notice how similar these are in terms of the pieces. A constant in the numerator, a number, and something squared. And, of course, that's square root. Now, I attack these in kind of three parts. The first thing I like to do is I like to make sure that the numerator is actually 1. So I'm going to accomplish that by just pulling the 2 out as a multiplier out front of my integral. The next thing I like to accomplish is I like to have 1 minus something squared. That's important. So deal with the numerator and then deal with this. So the way I'm going to accomplish that is I'm going to factor a 16 out. So I'm still going to have that 2 out front. I have a 1 on the numerator now, square root. I'm going to bring the 16 out, and I will have 1 minus x squared over 16, like that. Now, the square root of 16, of course, is just 4. That can be pulled out of my square root, and I can then, because it's a constant multiplier, I can pull that out of my integral. It was in the denominator like that. So 2 over 4 is 1/2. And I am going to, now that I've dealt with the numerator and I've got 1 minus, I'm going to aim to get something squared. So instead of writing x squared over 16, I'm going to think about taking the square root of each piece and saying that x squared over 16 is the same as x divided by 4 all squared. And now I'm going to use substitution. If u is equal to x over 4, then du is equal to just 1/4. And the way I always handle this is I think I would like the numerator to be exactly what I see here. I'd like to just replace the whole, the dx thing with du. So instead of 1 dx, I want 1/4. And I can multiply this as long as I also multiply by 4 out front, because 4 times 1/4 is multiplying by 1, and I have not changed anything. So 4 times 1/2 is 2. And this is 1 over the square root of 1 minus u squared, which is 2 times the inverse sine of u. Resubstitute back in, x over 4, and there we are. Let's do this tangent one. Again, regular substitution won't work because I don't have an x in the numerator. This is unfactorable because factoring is attempting to find zeros, and that doesn't work here because of this plus. So I'm going to, again, aim it towards tangent because it doesn't have the square root and it's plus. So first thing, once again, deal with the numerator. Let me pull the 3 out. Like that. Next thing, I need this to be a 1, so I'm going to factor a 9 out. Now this time, I don't have a square root, so it actually is a little bit easier to simplify. (36 divided by 9). Yep. Now I'm going to pull that 9 out. Again, it was in the denominator, so it'll be almost like 1/9. So 1/3. And once again, I want to get something just squared here. So what squared is 4x squared? 2x. Now I do my substitution. If u is equal to 2x, du is equal to 2. I'd like there to be a 2dx. I can offset that with a 1/2 up front. So this becomes 1/6, 1 over 1 plus u squared. The antiderivative is inverse tangent. And resubstitute back in. Plus c. All right, now let's have you try a couple. Pause the video here and try these two problems. All right, I will show how I would work these. If you haven't already, please like and subscribe for more math help. Okay, first thing I would do, just verify that none of our regular kind of substitution and factoring techniques will work. It looks a lot like inverse sine. That's what I'm going to aim for. So pull a 6 out. I'm going to factor a 9 out of the denominator. Don't forget your square root. Square root of 9 is 3. Pull the 3 out. Use substitution. I'd like a 1/3. So I offset that with a 3 out front. So I've got 6. So inverse sine of u like that. All right, next one. Pull the 4 out front. Factor a 3 out. Pull that 3 out as well. Now this is not going to be quite as clean, and I did that on purpose. So we have square root of 3 times 4 over 3 which of course I'm going to rewrite with the root after. We've got inverse tangent. Resubstitute back in. There we go. If this video helped you, please like and subscribe for more math help.